Welcome to today's session. So we continue looking at the 2021 Grade 12 GCE Mathematics Paper 1. And today we are looking at question 20 and 21. So question 20 reads, the points P and Q have coordinates 2, 6 and negative 3, 6 respectively. Find the distance between P and Q. The distance between P and Q. So let us call the distance PQ, we shall call it just D. So D, so basically distance square, so in this case, the square of the distance, which we shall call basically distance square, will be given by the difference between x2 minus x1, we square that difference plus the difference between y2, the change in y1, we square that. So basically, that's how we find it. So let us call this one to be x2, the point q to be 0.2, then p to be 0.1. So we have negative 3 minus 2, we square that, plus basically negative 6 minus 6, we square that. So negative 2 minus 3 minus negative 2, we get minus 5, which we square. When we square that, we get a 25. Then plus negative 6 minus negative 6, we have negative 12, which we square, we get basically 144. So basically distance square, d square is equal to basically 25 plus 144 is 169. So looking for distance, so find the square root. So basically d is equal to 13. Now since the distance, we cannot get a negative, so because there are two square roots of 169. Negative 13 times negative 13 is 169, or 13 times 13. So because it's a distance cannot be a positive number, so we have 13 units. So those units, we don't know. Can be meters, can be centimeters, so just those units. So that's part A, 20. Let's go to part B. So that's how we solve part A. Part B, the areas of the faces of cubes A and B are 9 cm square and 25 cm square respectively. Find the ratio of their volumes. Again, this question comes over and over. It could be maybe the ratio of the areas to ratio of the length, or the ratio of the areas to ratios of the volume. So again, we have 9 square to 25 square, and this is for A and B. So the first thing that we need to find the length, the ratio of their length. Okay, so to find the ratio of their length, because the faces, we multiply these two faces. Remember, the cube has got equal length and with breadth, so it's L times L, that's area, which is just area is equal to L square. Length and breadth are the same, and in this case, so what we do is we find the square root of this to find the ratio of their length. So square root of 9 is a 3, then square root of 25 is a 5. So the ratio of their length is 3 to 5. Now the cube has got the length equal to breadth equal to the height, such that the volume of the cube is L cubic, where because the length, the height and the breadth are the same. So to find the ratio of their volume, so now volume, what you do, you cube, because to find the volume of A, you need to multiply 3 by 3 by 3, which is 27. So it's 3 cubed, then 5 cubed. So we have 27 to 125. So there is no number that can go into 27 and 125. So basically this is their lowest ratio. So basically this is how you find the B. So it's 27 to 125 as the ratio of their volumes. Okay, so basically that's the case. Let us move to question 21. So 21 reads, write the 4 inequalities that define the unshaded region R on the diagram below. Okay, again this question comes over and over, so it's a matter of just us understanding how to answer this question. So let us go over this question quickly. So if you look at this question, we have, this is 5, which is basically 0, or 5, 0, then this is 0, 3. Okay, so let us start with this one. This the first inequality. So this first inequality, we shall call it 1. The first one, what we know is the shaded part is the one below this line, and this line is a 1. Okay, this is a 1. See there is a 1. So what it means is we want the numbers that are greater than 1. So in this case, x should be greater or equal to 1 because it's a solid line. It's not a broken line like this one. So it's a solid one. So that's the first inequality. Remember, we are trying to get the 5 marks. The second one is this one. So see this one, the numbers that are above 5 to the left of this one are above 5. To the right they are above 5. To the left they are below 5. So we want the one that are below 5. So in this case, inequality 2 becomes x is less or equal to 5. X is equal or less to 5. Equal or less 5. That's the number 2, which is there. Then let's come to this one. So this one we are looking for y. Remember, this is the y. The variation is in the y-axis. This one, the variation is in the x-axis. So here is the x here does not change, remain fixed. But as we are moving along this up and down, it's a y which is changing. So what we want the number that are below, not above. And what you can see from here, what's the value of y here? What you can see here, the value is a 4. Okay, we can see the value of is a 4. So in this case, we are looking for number 3, which is 3 points now. Number 3 is y should be at most equal to 4. So meaning the highest value y can take is a 4, because this is again a solid line. So y should be less or equal to 4. Y is less or equal to 4. So that's 3 points. So let us now find the fourth one, because we are required to find 4, which has 2 points, I assume. And this is the one that has dotted line. So this one is not a horizontal or vertical line. So the others, the first 2 were vertical, then the other one was horizontal. So this one, we need to find 2 points. We need to pick 2 points. We need to find first of all the gradient, then we find the equation, then we find the wanted region. So we shall pick this point. So this point is basically the value of x is 0, then the value of y is 3. We shall call it point A. Then at this point where this line is passing, the value of x is 5, the value of y is 0. We shall call it point B. So let us find, and this will be 1, this is point 2. So we need to find this equation, y is equal to mx plus c. So then we need to find the gradient. So gradient is equal to y2 minus y1 over x2 minus x1. So what is y2? It's 0 here, minus what is y1? 3, over what is x2? It's a 5 minus 0 at this point. So we end up with negative 3 over 5 as our gradient. So then, having found the gradient, we can just pick 1 point. So it's easier to pick the point where x is 0, because it's much more easy. So we have y is equal to, remember, wherever there is m, we are putting minus 3 over 5, x, then plus c. So y is 3 is equal to, at this point at a, then minus 3 over 5, then what is x? X there is 0 plus c. Then 3 is equal to, then this whole thing is 0 plus c. So c is equal to 3. Okay? So if c is equal to 3, we have now this equation, y is equal to minus 3 over 5 multiplied by x plus c. So remember this equation. Now this equation is a straight line, just this straight line. But we need to find the inequality which will give us the area of interest in a set of values that we're interested in. So, and this is a dotted line, a broken line. So meaning it's strictly greater or less. So let us pick the point in the unwanted, okay, let's say the wanted region. So this is the region that we want. So we can assume this line where x, so where x is basically x, this point we shall call x. So this point will be basically 5, 3, where these two are intersecting. Okay, then substitute. So the value of y is 3. Okay, then we want to know what are we looking for. So it will be basically negative 3 multiplied by negative 3 over 5 multiplied by 5, then plus 3. So this one and this one is a 1. So we have negative 3 minus negative 3 plus 3, we are getting a 0. So what we end up with this one will be basically this will be 3 then box 0. So which one is correct here? Is it 3 is greater than 0 or 3 is less than 0? So 3 is greater than 0. So basically this is our equation now. This our equation becomes y, which is the fourth one, becomes y is greater than minus 3 over 5x plus 3. This is our fourth inequality. So basically this is how you get the four inequalities to get those 5 marks. Thank you for joining us. Please join us as we look at question 22 and 23 in the final episode.